All right, let's go ahead and write the inequality for this graph. And the first thing I notice is that the line ends over here at 2. Right there, that's where it ends. So I'm expecting a comparison with x and 2. Now, you may not use x. You can use whatever letter you want, but I'm going to use x. So we're comparing x with 2. That's where it changes from green line to no line, meaning looking at truthfulness, and then it switches into falsefulness right there. Now, this line here it's going to the left. Okay, so since it is going to the left, the inequality cannot eat the x. Okay, so it's got to be eating the 2. So right now that shows x is less than 2, but that's just the line part of the graph. The closed circle here tells us that x could actually equal 2, and that would be true as well. So that's as much as we need in order to write the inequality for this graph. Okay, there's our objective for the day. I can solve and graph inequalities, and then we see that we got a mastery quiz next time. So keep that in mind. Take 15 seconds, copy down the objective, but keep in mind that we have a mastery quiz on this stuff next time. Okay, we have solving equations, right? So this is the stuff that we've seen already. We know first we need to look for distribution. If there is no distribution, then we can skip that step. Same with combining like terms, although when we're isolating the variable, we're looking also to combine like terms. We're just using these principles of equality down here. So we combine like terms to simplify the problem. We isolate the variable, meaning we usually want the x's on one side and the numbers on another side. I generally put the x's on the left and the numbers on the right, but it doesn't really matter. And the last thing we would do is force the coefficient to be a 1. So this one is showing solving inequalities, and there's only one thing. It's not even different. It's just that it's been added to what we saw with solving equations, and that's this step right here. If the coefficient is negative, then we need to flip the inequality. So everything else remains the same, meaning that if we use addition and subtraction, this is to make zeros, and this is also how we isolate the variable. So again, that's just how we get the variable all on its own side. So again, that's for the addition and subtraction principles of equality there. I guess I'll get rid of the parentheses. And then this last part right here, force the coefficient to be a 1. That way we can make it a phantom 1. Generally speaking, when that happens, we use division, but it is also possible to use multiplication in that step as well. So multiplication and division, principles of equality, that is how we make or force values to become 1s. Generally, again, that is for the coefficient, which if we have forgotten what a coefficient is, then it's a value that's being multiplied by a number. So for example, if I had like 3x, 3 is the coefficient. So the last note, again, I just can't emphasize this enough, is at the very end, if you have a coefficient that is a negative, because we're going to be either multiplying or dividing by a negative, that's going to flip the inequality, okay? So you're just really looking at the end. If the coefficient is a negative, it doesn't really matter which side it's on, then you need to flip the inequality. So we reviewed solving equations in the last lesson. Now we're going to look at it in this same context. So you see, this is an inequality, and I'm comparing it with an equation. But again, there's only one difference in this process. So everything is going to be the same, meaning on the left here, I would solve this like an equation. There's no distribution. There's no combining like terms, so I just need to isolate the x's. And again, for me, I like to put the x's on the left, numbers on the right. Now, you can put the x's on the right and the numbers on the left, but I'm going to do exactly the same thing with the equation on the right. Okay, so again, x's on the left, numbers on the right. And when I say left and right, I'm talking about this line. That's the inequality line or the equality line over here. So I go through each of the terms and see if it's on the correct side. If it's not, I have to zero it out with either addition or subtraction principles of equality. So here, I'm going to show this as a 1x actually. It is an x term, but it's on the x side of the line, so it stays. But the 9 is not, it does not have an x, no x for the 9, meaning I have to zero that out. So I'm going to subtract 9, but I have to do it from both sides. Now again, I'm subtracting 9 from the negative 2 because it is not a like term with a 10x. But you'll see over here with the equation, that's what we would have done with the equation as well, right? So what does this do? It allows us to take that 1x and drop it. None of this is going to change the inequality, so I can keep that there. But it did zero out the 9 for us, which is what we wanted. Then I can drop the 10x and negative 2 minus 9. You put that in the calculator, you get negative 11. So what's different on the right side? Well, same thing just happened. We zeroed out the 9s. We can drop this. I'll drop it as 1x. It equals, we can drop the 10x, and negative 2 minus 9 is negative 11. So you see that this inequality and this equality, nothing really changes, right? And they're not supposed to when using addition and subtraction principles of equality. So addition and subtraction principles of equality, they never change the equations. Now, you may have gotten something a little different depending on if you put the x's and numbers on, say you put the numbers on the right, on the left and the x's on the right. Yeah, you may have gotten something different right there, but our final answers need to look exactly the same. So proceeding here, I would now look at this new inequality and the equation, which is going to work the same. But in the inequality, I have the x side. I've got the 1x. That's okay. On the number side, I have an x term, the 10x, so I need to zero that out. So I'm going to have to subtract 10x's there. But if I do it to one side, I got to do it to the other side. And it works the same way on this equation too, because the black 10x is on the number side of things here. So I can't have it there. It's not just a regular number. So what happens now? Well, I've got 1x's minus 10x's, which is negative 9x's. Again, that will not affect the inequality. I've zeroed out the positive 10x, but I can now drop my negative 11 there. So everything else is going to be the same with the equation. It's just an equal sign instead. So 1x's minus 10x's, negative 9x's. This would then equal, we've already zeroed out the 10x, and again, we drop the negative 11. Okay, so again, everything is the same. At this point, though, this is where things will be a little different, because if we were to look at the equation, we generally would just say, you know what, we're going to take the coefficient negative 9 and just divide it by itself to make this 1x, and that would work, as long as you remember to do it to both sides. So negative 11 divided by negative 9 as a fraction, which is what I'm going to use, I have 11 ninths. Or you could say 1.1 repeating, but I don't like that decimal. It's fairly ugly to me. Now notice with the inequality, we're going to do exactly the same thing. It's just by showing you right here that we're dividing by negative 9. Okay, so the values are going to be the same, 1x, and then we're going to get 11 ninths there. But since we did divide by a negative 9 instead, the inequality needs to flip. So now instead of it being a greater than symbol, it's now a less than symbol, and that changes for us, okay? So everything about the equation was the same, except for the inequality at the very end. By dividing both sides by a negative, we then have to flip the inequality. So on that last slide, we said, just look, see here, that was a negative 9 coefficient. It's negative, and that's what will flip that inequality, which is kind of the same thing, just in a different way. So you can look for the negative here, like we said to in that last slide, or you can say, look for the negative in your division, or what could be multiplication, and it's going to do the same thing. It's going to flip that inequality, but it's only the 9 that's negative that makes it flip. I don't care about the 11 being negative. If this were positive, the inequality would still flip, because this value does not affect the inequality, but it does, of course, affect the sign of the answer. But that's not what we're looking for. We're looking for flipping the inequality. So we're going to solve some of these equations. Let's see how we do. And we'll just need to remember, with inequalities, same idea with solving equations, just at the very end, if I have a negative coefficient, I will need to flip the inequality, or we can say that if we ever multiply or divide both sides by a negative, that the inequality must be flipped. So on this one, I start by noticing that I have my parentheses here, and I will then need to know that I'm distributing a negative 4. Distribution is multiplication, which you can see right there. So I'm going to distribute. Negative 4 times negative 10 w's would be positive 40 w's, and I'm putting the plus sign there because I have the negative 7 in front. We'll get to that. Then I've got negative 4 times negative 5, which would be positive 20 there. So my new inequality, I have negative 7 plus 40w plus 20 is less than or equal to negative 6w minus 9 plus 10w. Okay, so that's all the distribution I had there. I now look to see if I can combine any like terms. I'm going to start on the left side, and I see I've got these constants that I can combine. It's negative 7 plus 20, which would give us positive 13. So the 40w just stays the same. It's positive 40w plus 13 is less than or equal to, and I can combine my w's here on this side. How many w's is that? Negative 6 plus 10. That'd be positive 4w's, and then we got a minus 9er there. So this is my inequality. Now it's similar to what the inequality that we solved in that last slide, but I've already done the distribution and the combining like terms. So I'm now ready to solve this by isolating my w's. Again, I will be putting my w's on the left and the numbers on the right. So the 40w has a w, it's on the w side, so it can stay, but the 13 has to go because it has no w. So I subtract 13, and it is a principle of equality. So if I do it to one side, I must do it to the other side. Now moving from left to right, I can drop my 40w's, positive. We've zeroed out the 13 positive. Again, none of this is going to affect the inequality, but I can now drop my 4w's as well. And negative 9 minus 13, that would give me negative 22. So we're pretty close. Next up, I will, so the 40w is good, but I have to take this 4w and zero it out because it's on the number side of the line. So I'm going to subtract 4w's from both sides. So again, how many w's is that going to make? 40 minus 4 would be 36 w's. And this is less than or equal to, well, we zeroed out the 4w's as planned, and then I've dropped the negative 22. So this isn't going to come out very pretty, but it's still going to work. At this point, I'm going to divide both sides by 36. Now in doing so, I'm dividing by positive 36. The coefficient is positive, so this will not flip the inequality. It will remain a less than or equal to symbol, but at least now I have a 1w, and negative 22 divided by 36 as a fraction, negative 11 over, looks like 18. Okay, so that is the inequality. Let's give ourselves some space for the graph then. Okay, so my graph, see if I can do a fairly straight line at least. Whatever, that'll work. Now, right in the middle of that, I'm going to put my negative 11/18. Okay, and that negative 11/18 is showing an equal part of the inequality, so that's going to be a closed circle there. The inequality is not eating the w, which means that the line must go to the left. Okay, so the purple line and dot would be the inequality. W is less than or equal to negative 11/8, and that's good enough right there. We have the inequality in the graph. Boom. Okay, take a minute, try this one out, then we'll go over it. Okay, 1 minute. All right, I'm going to get started on this one. If you need to pause the video, do it. But I'm going to get started here. We have the parentheses. That's okay. It tells me that I must use some distribution. So first thing in solving any equation or inequality is use distribution first. So I've got to distribute the 3 into the 8t and the negative 9. Starting with 3 times 8t's, that would be positive 24t's. And then 3 times negative 9 is negative 27. So again, I put the positive 24t as plus because I need to remember that I have that 8 out in front. Okay, so this is my new inequality. I've got 8 plus 24t minus 27 is greater than or equal to 9t plus 7 minus 4t. And I'm ready now to combine like terms again. I have 8 minus 27, which in my calculator would show negative 19. I can drop my positive 24t's. And again, none of this stuff is going to affect my inequality. But then I have 9t's minus 4t's. So how many t's is that? 9 minus 4 is 5t's. And I still have the plus 7. Okay, so again, the distribution and the combining like terms is meant to simplify the inequality here, which we did. We had, I call that 5 terms, and we're down to 4. Now I'm going to isolate the t's. So to do that, I'm going to put my t's on the left and then the numbers on the right. Again, you can switch if you'd like, but I'm going to keep it like this. The 24t in red is a t term, so it stays, but the negative 19 in purple, it does not have a t, so I'm going to have to add 19 to both sides of the inequality. So I can drop my 24t. Negative 19 plus 19 is 0, so this is going to be greater than or equal to, and none of that affects the sign or the inequality there. I can drop my 5t, and 7 plus 19 is going to be positive 26. So it looks like we may end up with a fractional value again, no problem. So here again, principle of equality. The problem is the 5t is on the numbers side of things. So I've got to zero that out by subtracting 5t's, but from both sides. So 24t minus 5t's, how many t's is that? 19 t's. So this would be greater than or equal to 5t minus 5t. 0 is planned. Then I can drop my 26. So yeah, it looks like our fraction won't even be simplifiable. No problem. Last thing I need here is a 1t. So to make a 19 a 1, I divide it by itself. But if I do it to one side, I must do it to both sides. Now that's positive 19, so that stays, or the inequality stays a greater than or equal to symbol. 26 minus, divided by 19, rather, it really doesn't simplify. It's just 26/19. So that's our inequality, and it's telling us that all values of t greater than or equal to 26/19 will work for the original inequality. And now that I have that, I'm ready to graph here on the right. So again, right in the middle, I would put that value 26/19. And I see that it's got the equal sign again, so I'm looking at a closed circle there, 26/19. But this one's eating the t, so I'm going to show the graph a little different here. Just kind of going up like this. Some students prefer to just write it on the line. If you have different colors, that kind of helps. But if you don't, some students like to do it like this, and that's fine too. So this is the graph. All values bigger or to the right of 26/19 on the graph would make the original inequality appear true. And then on the other hand, if you were to replace the t's up here with positive 26/19, it would have made the inequality equal, which also makes it true. That's why we got a closed circle there. Okay, let's do this one together. We're going to solve and graph this inequality. I do see I have some parentheses there, no problem. It just tells me that I'm expecting some distribution. So I can distribute the 2. I'm going to show that as 1a. So I'll start with 2 times 1a, which is 2a's. And then I have 2 times 5, which would be positive 10. And kind of like the other problems, nothing to do here, just on the left side this time. So I now have 8a minus 10 minus 6a is greater than 2a plus 10. And I even have on the left, no distribution, but I have these like terms that I can combine. How many a's is that? 8 minus 6, which is positive 2a's. And then I can drop my, again, that's a negative 10 because the minus sign goes with the 10. And so this is greater than, looks like 2a plus 10. Now, some of you noticed something about this equation, inequality rather, and that's okay if you do, but right now I'm just going to proceed as though we didn't notice anything. I'm going to put my a's on the left, numbers on the right, and here, since my negative 10 in black does not have an a, I've got to zero it out. So add 10 to both sides. So that zeroes that out. I'm left with the 2a in purple, and none of this affects the inequality, so it's still greater than, and then the other 2a in red. But 10 plus 10 is going to make that positive 20 there from the principle of equality, okay? Now, the next up, I have 2a in red on the wrong side of the inequality because it's on the number side of things. So I've got to subtract 2a from both sides. Okay, now 2a minus 2a, you could say that's 0 a's, that's fine, but it's now showing that that is greater than, we just zeroed out the red 2a's and we can drop the 20. So at this point, you could say, you know what, I'm going to divide both sides by 0, but I don't necessarily want to do that. What we're showing here is that something times 0 is greater than 20. There we go. And as far as I can tell, this one right here, This is never true. Another way to say that is that it's always false. So since it's always false, this one actually, it just has no solutions. So in that, what this means for us is that since it has no solutions, if it were to ask us to graph this on a number line, we actually have to leave it blank. And we don't even put 20 on here. It doesn't matter what you put on the graph. We leave it blank because no values on a number line will ever make the original inequality true, because once we kind of narrow this down to 0 times a letter, there's nothing I can do to make 0 times anything to be ever bigger than 20. I can't do it. No matter how big or small I make the a. I can make it a fraction, a decimal, doesn't matter. I can make it a negative, positive. Doesn't matter what value of a I use. I can never make this bigger than 20. So there just is no solutions. All right, this one's kind of large, no problem. I do see, once again, that I have some parentheses, so I'm expecting some distribution with the 6. So that'd be 6 times 1x's, which would be 6x's, and then also 6 times 5, which would be positive 30. Nothing else changes. Let's see if I can copy this correctly. Looks pretty good. All right, so my new inequality after the distribution, 6x plus 30 minus 12 plus 14x, is less than or equal to 10x plus 15 plus 3 plus 10x. And now that I've done the distribution, I'm looking for combining like terms. So here I've got my 6x and 14x's. So that'd be 6 plus 14x's, which would be positive 20x's. And then also 30 minus 12, which should be positive 18. Now, the order that I've written these in doesn't really matter. Some students would write this as 20x plus 18. That's not going to matter. And the inequality hasn't been changed yet either, or affected. But now on the right side, I've got 10x's plus 10x's. So how many x's is that? 10 plus 10 would be 20x's. And then I also have 15 plus 3, which would be positive 18 there. Now, I've kind of purposely written these in different orders. Some of you may notice what this is right here. Okay, and we've seen this already with, I think it was our first unit, actually. But I'm going to proceed as though we didn't notice anything, so let's continue here. X on the left, numbers on the right. So the 18 must be zeroed out because it's on the wrong side, because it's on the x side. So I'm going to have to zero that out. So I'm going to drop my 20x's in purple. Again, none of this affects the inequality. And I drop this other 20x in purple. 18 minus 18, I'm going to show that as plus 0 because it is on the number side of things. I need some number to represent here. Excuse me. Next up, on the side of the line, I've got this 20x, but it's on the number side, so I've got to zero that out. So minus 20x is there from both sides, making now 0x's is less than or equal to, we already zeroed this part out, but I can drop my green 0, okay? So with this, what we have now is something, we're showing the x is something, times 0 is less than or equal to 0. Now, the less than part isn't really important here, but what we see is that the equal part is true. In fact, it's always true. Anything times 0 is 0. So this one is always true. Okay, or you could say never false if you like. But either way, what this is telling us is that the solution here, we're going to say it has infinite solutions. But we have to be careful with that because all of the inequalities have infinite solutions. So we can say that there's infinite solutions. The truth is that the solutions that are going to work for this one, x, is any real number. Okay, so it's not limited to certain values like most inequalities are. This one's good for any real number. Now this means that when we go to the graph, which I'm going to do here on the right, again, it doesn't really matter where your 0 is or what values you're looking at on the number line. So I can even put 1 and -1 here. That doesn't matter. The graph is all real numbers, meaning it spans from -infinity to positive infinity. And you can put that blue line on the graph or above it like I did. It doesn't really matter when you're doing it by hand. But again, this is any real number. Okay, now that completes this lesson. So we should be able to solve and graph inequalities at this point. Remember that we're going to have a mastery quiz on this next time. You guys do the assignment on Canvas. Get this done so you don't have to take it home, so you can spend time with your families without having to worry about any math stuff.